Hi there, my name is Anna. I work for the Portland Water Bureau. We are the folks that are responsible for delivering water to your taps. You may wonder when you turn that water on, where is it actually coming from? Well, it mainly comes from a river up near Mount Hood called the Bull Run, and that is in a protected forested watershed. We also have another drinking water source called the Columbia South Shore Well Field, and it's located along the south shore of the Columbia River near the Portland Airport. Wells are dug deep into the ground and tap geologic layers of rock that contain water. And these layers are called aquifers. All right, so now that we know what an aquifer is, we are going to do an activity that demonstrates how groundwater works. We are going to build an aquifer. Let's first gather the materials. So what we'll need are hopefully things that you can find in your home. So you need a clear container. This is glass, but you could also use plastic. A spray bottle, 2 different colors of food coloring, a scouring pad, a glass. And now we'll need some things to represent our different geologic layers. You might be asking yourself, what is a geologic layer? You probably know what a layer is, but geologic might be a new word for you. So let's break it down. The word geologic comes from the word geology. Ology means the study of, and geo means earth. So geology is the study of earth, and more specifically, the study of rocks. By studying rocks, geologists can find clues about how the rock was formed. I bet you've heard of the water cycle before, but did you know there is a rock cycle too? One part of the rock cycle is when mountains get ground down into smaller pieces of rock by glaciers, or flowing water, or wind, or even gravity. When rivers flow, they pick up rock and carry it downstream, breaking it up into smaller and smaller pieces. When the water slows down, these rock pieces fall to the bottom of the riverbed because of gravity. This creates a new layer of rock that becomes part of the land. This process happens over and over again over millions of years, and eventually buries older layers of rock deep underground. Geologists can dig up that rock and use clues about the shape, size, and type of rock to understand how that particular piece of land was formed all those years ago. Here in Portland, these geologic or rock layers that we take drinking water from might be deep underground now, but those rocks were brought here by the ancient Columbia River thousands and millions of years ago when the land looked very different. This image is of what we like to call a layer cake of buried river and lake deposits. The sand and gravel layers were formed when the ancient Columbia River was flooding and moving really fast, eventually depositing big pieces of rock like gravel and sand. These sand and gravel layers can store water. We call them aquifers. We drill wells down to these aquifers so we can pump water out for us to drink. At other times, the ancient river looked more like a lake and moved so slowly it could only carry and later deposit small pieces of rock, like silt and clay. Water doesn't move well through these silt and clay layers, so we call them confining units. Now that we know a little more about geology, it's time to get back to our activity and talk about what else we need to build our own layer cake. So we need some molding clay, and you could use silly putty too, but you want it to be about the same size as your container. And we need some things to represent different sizes of rock. In this jar, I have some smaller pieces of rock that I found in my garden. So I have kind of a bigger piece and some smaller pieces, so kind of a mix. And so to represent my rocks, I am going to use two different sizes of dried beans. So for my larger pieces of rock, I have some chickpeas. And for the smaller pieces of rock, I have some smaller beans. So I mix those together And those are going to represent my gravels and pebbles. Now I also need something to represent sand. So we're all familiar with sand. We've seen sand, we've played in it. This sand I got in my garden, we are going to use rice to represent the sand. It doesn't matter what kind of rice, as long as it's just smaller than the beans that you use or whatever you use to represent your bigger pieces of rock. It also helps if what you end up using to represent your geologic layers are light in color. So once you have all those things gathered, come back and we'll be ready to start the activity. Okay, great. You have everything to make your aquifer? Let's do it. So we are going to start off by taking the sand and we're going to pour it into the container. And then, so we can see the water a little bit better through the experiment, I'm going to add some of this green food coloring to my water. And then I'm going to pour it into sand and see what happens. Wow. It just soaked right in really quickly. Let me try that again. You should try it too. So where do you think that water is going? I'll let you ponder that thought for a moment and then we'll move on to add the next layer. Okay, so now we're going to add our clay onto the top of our sand. And you want to just make sure that your clay is going to be big enough to cover the entire layer of sand and then also to be able to kind of stick it to the side of the container on the inside. So go ahead and just kind of press the clay against the glass. And then once you have that all secured, you're going to go ahead and pour some water on the clay and see what happens. Wow, what do you notice? The water is just ponding on top of the clay. So why do you think the water was able to soak into the sand but not the clay? Well, the sand has a lot of spaces in between each of the sand grains. And so the water is able to take up that space between the sand grains. Those spaces are really well connected, so the water is able to flow through. However, with the clay, there just aren't a lot of connected spaces for the water to be able to get into the clay. And you can see that because the water is just sitting on top. So when we were talking about what an aquifer is, we were saying that an aquifer is a layer of rock or sand that is able to store water. So do you think that our sand or our clay would be considered an aquifer? Right. Sand. So the clay is actually what we call a confining layer. And that just means that it acts like a barrier to water moving down. Kind of like a raincoat that you would wear when it's raining. Keeps you from getting wet, right? So the clay prevents the water from getting down. And it just ponds up on top. Okay, so now we're going to add our gravels and pebbles. And what I want you to do is just to create sort of a mountain on one side and a valley on the other. So you're going to kind of mound them up on one side, you know, like as if you wanted to build a little mountain top or a nice place to hike to or build your house. And then this low-lying area will be kind of like a valley. And now, pour the water into our rocks. So I'm going to start from the mountain. And you'll notice there's kind of a lake that's forming at the bottom of the hill. Oh, a little landslide happening too. You're just going to fill up the water, fill up your container. So if you guys see, the water has filled in the spaces between my gravels and pebbles. So that water is what we would call groundwater. Also, the water down in our sand is also groundwater. But that layer in between, that clay, is a confining layer. That's preventing the water from getting down any deeper. And then on the other side, you can see that we have a lake that's formed. And that's what we call surface water. And ponds, rivers, streams, wetlands, they're all considered surface water too. But obviously, our groundwater is connected to our surface water. And you can see the water rises in our gravels and pebbles to the same level that it rises in the lake. So the Water Bureau is able to access groundwater to provide drinking water by drilling a well into the ground. And that well is kind of like a straw. This pipe is put into the ground and it has a pump and a motor. So that pump is able to pump water out of the ground and then deliver water to your tap. The Water Bureau also pumps water from aquifers that are below confining layers, like our sand aquifer here, in the very same way. So they would just basically drill a well and it would go through the clay layer and into the sand, and that's where the water would come from, deep underground. And the same thing, it would just pump the water out. Okay, so now we know we need lots of spaces between our geologic layers in order to store water. We understand how clay acts as a confining layer that actually is a barrier to water and can separate aquifers from one another. And we know that the Water Bureau drills wells into these layers and pumps the water out to provide your drinking water. So now I want you to think about what are some things that you can do to help protect your drinking water. So I did a quick walkabout in my home and looked for different chemicals that I use, and these are all helpful to make my life easier. I have a weed and grass killer that we use to put on our lawn to kill weeds, some organic fertilizer to make sure that my garden grows really nice and I get lots of tomatoes and vegetables every year. I have some drivetrain cleaner. So I like to ride my bike quite a bit, and I ride my bike all around, and actually it prevents me from having to use my car as much. But I need to clean the grease that builds up on my chain off, and I use this drivetrain cleaner to do that. I have a deck sealer, so to make sure that the wood on my deck can withstand all that rain that we get here in Portland. So all of these products you find in your home and they are helpful. However, if you don't use them properly, you use too much, or you don't throw them away in the right place, they can actually have a bad impact on our drinking water. So let's demonstrate. So I planted some grass onto the top of our mountain here. So say I accidentally add way too much weed and grass killer. Then it starts to rain. What do you think is going to happen to that extra weed and grass killer? Yeah, it's going to start to soak into the grass, into the soil, and make its way down into our groundwater, into our aquifers. And you can see it's already started to make its way down through our gravel and pebble aquifer. And what's happening at the clay layer? It's just sitting on top. Oh, and then looks like there's a little break in the clay layer, and that weed and grass killer has gotten in to my sand aquifer. Oh, it's starting to leak into our lake as well. So then we turn the groundwater wells on and start to pump that water out of the ground. Let's see what happens. Now look at our drinking water. Would you want to drink that? I wouldn't. So be really careful about the different chemicals that you use in your home and make sure that they are used correctly and they are disposed of correctly. And there's a neighborhood cleanup, and you can bring your chemicals to those neighborhood cleanups and they will properly dispose of your chemicals once you are done with them. My job at the Water Bureau is to help make sure that we have enough water in our aquifers and that it is safe to drink. We do this by measuring water levels in our monitoring wells and by testing for pollution to make sure the groundwater is clean. And even better, by spreading the word to businesses and families, we can make sure all of the people working and living near the drinking water wells know how to use and dispose of chemicals safely, so we can all prevent pollution from ever getting into our groundwater. So now you know a little bit more about groundwater, Portland's second source of drinking water, and how you can help us protect it.